Okay, Assalamualaikum and hi everyone. Alright, today I'm going to discuss about tutorial 7.1G. For this tutorial, it cover for the calculation involving pH, dissociation constant KAKB, initial concentration and concentration at equilibrium, and degree of dissociation. So we take a look at the first question. Write an expression for the dissociation constant Ka for propanoic acid. So this is the formula for propanoic acid. Right, so first of all, what should you do? So you should start with the weak acid dissociation equation. Right, so we have CH3, propanoic acid. Okay, so exists in aqueous, dissociate in water. Water here is in liquid, and because this is dissociation of weak acid, so this reaction is reversible, so you have to use reversible arrow. And then because weak acid will donate a proton, but which one? So proton that is attached to OH group, which means here OH group here. So therefore it will form an ion OO. And then because water, it has lone pair and water react as a base, so it can accept a proton from weak acid. So and become H3O plus. This is in aqueous. Right, next you can write the Ka expression for this equation. So Ka, so remember concentration of the product divided by concentration of the reactant. Right, so divide by concentration of reactant. Alright, since H2O is in liquid, okay, so therefore it is not included in the Ka expression. So therefore you'll get here divide by concentration of propanoic acid. Okay, right, so this is for A. So for B, we take a look at the question. Okay, calculate the pH. pH of 0.35 mole per liter solution of propanoic acid at 25 degree. Given to you the Ka values. Alright. So what should we do? Because we want to calculate the pH, so we have to know the concentration of H3O plus at equilibrium. So this one, we have to know the concentration H3O plus at equilibrium. Right. So the given concentration here is referred to the concentration initial. Alright, so therefore you have to solve this problem by using ice table. Okay, so first of all, start with the equation. Okay, so you must include with the phase. And your equation should be balanced. Alright, so second step, you have to draw the ice table. Alright, so here is the ice table. Okay, now substitute the concentration. So initial concentration here is 0.35. As for the H2O exists in liquid, just write dash. For the concentration of the products is 0. Not dissociate yet. Okay, for the changes, for the propanoic acid, it will change negative X. H2O dash product will increase positive X. Alright, next at equilibrium. Alright, since this is a weak acid, so it will not 100% dissociate. So therefore we will get 0.35 minus X. This is X and this is X. Right, so when we want to calculate the pH, actually we have to find out the concentration of H3O plus at equilibrium. Right, so which means the value here. What is the value here? Okay, and then already given to you the Ka. So Ka is already given. Right, so therefore when we want to solve the value of X, then you have to refer to the value of Ka expression. So therefore you have to find out the concentration of this product as well as the reactant. Alright, so for the next step, what should we do? So you have to write the Ka expression. Okay, Ka is equals to concentration of the products. Okay, and then we substitute all the values here. Alright, 1.35 times 10 power of -5. Alright, so for concentration of the products here, we have to refer to the concentration at equilibrium. Right, so for the next step, right, so you have to refer to the value of Ka. So since Ka here is given time 10 power -5, so therefore you can use the approximation method directly without checking the 5% test. Alright, assume X is very small, then 0.35. Therefore, 0.35 minus X is approximately to 0.35. So, 1.35. Okay, so meaning that for this one, it's become 0.35. Right, so next we have to find out the X value. Okay, therefore you should get X is 2.1737, 10 power of -3. So when we refer back to the ice table, so the value of X here is referred to the concentration of H3O+. So actually this is referred to the concentration of H3O+. Okay, next step, you have to calculate the pH by using the formula of pH equals to negative log concentration H3O+. Okay, now substitute. Okay, so suppose you get 2.66, the pH value. Right, so for this kind of question, how many marks they are going to give to you? Okay, so the first mark for A, the Ka expression is 1 mark. For B, equation 1 mark, because equation is not included for you, you have to write by your own self, 1 mark. Okay, for the first row, for all the initial concentration here, 1 mark. Change, 1 mark. At equilibrium, another 1 mark. So Ka expression is already given from the previous calculation. So for the next mark is refer to the substitution. And then you make an assumption here, 1 mark. Alright, next X values. So you write the formula of pH and final answer. pH equals to 2.68. Right, so now we move to the second question. Okay, the pH of 0.1 molar, a weak acid, is 2.85. Calculate the Ka. So first of all, what should we do? So you have to write the weak acid dissociation equation, since here is given to you general. So you have to write general. Because this is weak acid, so it will dissociate partially, so therefore you have to use the reversible arrow. So acid will donate a proton to H2O. So H2O here react as a base. So this is a weak acid. Weak acid will donate a proton to base H2O. So it will become H3O plus and an ion A minus equals. Right, so next step, you have to draw the ice table. Alright, so here is the ice table. So now we substitute the initial concentration, that is 0.1. As for the liquid dash, concentration of product 0 because not dissociate yet. Okay, for the changes, for weak acid, decrease. Product will increase. At equilibrium, so this is weak acid, it will not 100% dissociate. So therefore 0.1 minus X. Product X. Alright, so now the question here is we want to calculate the Ka. You have to find out the value for each of the concentration of the reactant and also the product at the equilibrium. How to solve the X values? So it's already given to you the pH. So then you have to find out the X value by using pH. So first of all, we have to write the pH formula. Right, next, substitute. This one is already given to you, 2.85. Okay, after you have already substitute the value of pH, time both sides with -1. So we'll get log concentration H3O plus equals to -2.85. And then you have to move the log from the left side to the right side. So we will get like this. So log become anti-log. -2.85. Right, so anti-log here actually is referred to 10 power of -2.85 And therefore, you will get here 1.4125 times 10 power of negative 3. And don't forget, because what we already calculate here is refer to the concentration. So, must have unit molar. So, actually the value of concentration of H3O plus when refer to the ice table here, it is referring to the value of X. Right, so now you can write the Ka expression. So, Ka. So, as for the H2O is in liquid, is not included in the Ka expression. Alright, so substitute. Right, so this one is the value from the ice table. Since we already calculate the value of X here, so substitute all the values of X. So, this one become X squared. So, which means 1.4125 times 10 power negative 3 squared over 0.1 minus 1.4125. Okay, alright. So, suppose you get the final answer here, Ka 2.02 times 10 power of negative 5. How many marks that you will get here from this calculation? Right, so the first mark is given to you when you write the equation, 1 mark. Okay, and then for the concentration at equilibrium, 1, 2, 3, 1 mark. Change in concentration, 1, 2, 3, 1 mark. Okay, and the equilibrium, 1, 2, 3, 1 mark. Okay, next mark is when you write the pH formula, 1 mark. You find out the value of X, okay, 1 mark. Ka expression 1, substitution 1. Okay, next, find the answer. Alright, so next we move to the next question, number 3. Okay, calculate the percentage ionization of 0.6 molar hydrofluoric acid, given to you the Ka values. Right, so what should we do? So we know that percentage ionization is referred to the change in concentration over initial concentration time 100%. So right here, we already given to you the initial concentration here. However, we don't know the change in concentration. So therefore, you have to solve by using ice table. Right, so first of all, you have to write the weak acid dissociation equation H4HF. Because this is weak acid, so partially dissociate, then you have to use the reversible arrow. Alright, so acid here, it will donate a proton to water. Water here react as a base. So it will become H3O plus aqueous plus F minus ion aqueous. Alright, second step, you have to draw the ice table. So now, substitute the initial concentration. That is 0.6. Change. Okay, so because this is weak acid, so it will dissociate partially. So 0.6 minus X for the concentration at equilibrium. X. Alright, so now we want to find out our target here. Actually, we want to find out the value of X here. Because we want to calculate the percentage of ionization. Alright, so how to solve this problem? Then we have to use Ka values. So the next step, we have to write the Ka expression. So Ka, remember concentration of the products divided by concentration reactant. So water, remember, is not included in the Ka expression since it exists as a liquid. Alright, next, substitute. Right, so when the Ka value is equals to negative 4, then we have to perform the 5% test. Okay, let's say assume X smaller than 0.6. So therefore, 0.6 minus X is approximately to 0.6. Right, so let's say we substitute here. Find out the value of X. So therefore, suppose you get the X value here is 0.0262064. Alright, so now we already find out the value of X. So we want to know whether this approximation method can be applied here since given to you the Ka value is 10 power negative 4. Okay, so you have to apply the 5% test. So change here is refer to the x value here. So just substitute. Okay, divide by initial is 0.6. So the ratio here, you will get here 0.0344. So which is smaller than 0.05. So therefore, can use the approximation method. Okay, next step, you can find out the percentage of dissociation. So first of all, write the formula. Okay, then you substitute the values. Change in concentration is referred to the value of x here. So 0.02064 over 0.6, 900%. Then from here, you'll get 3.44%. Okay, how many marks are given to you from this calculation? Right, so we take a look. Right, so first, you write the dissociation equation, 1 mark. Okay, initial 1 mark. For 3, 1, 2, 3. Okay, this change also 1 mark. Equilibrium 1 mark. KA expression 1 mark. Substitution 1 mark. Okay, now you write the assumption 1 mark. Find out the x values 1 mark. Alright, next you do the 5% test. This is 1 mark. Okay, and then formula for percentage dissociation and final answer. Alright, so question number 4 here. What is the pH of 0.01 molar sodium diethylamine? So given to you the Kb values. And the Kb values here is 10 power of negative 4. So you have to be careful. You have to apply the 5% test to ensure that whether the approximation method can be applied or not. Alright, so first of all, you have to write the dissociation equation for the weak base. Okay, because this is weak base, it will not 100% dissociate. Then we have to use the reversible arrow. Right, so since this is a weak base can accept a proton. Why? Because on the nitrogen atom, there is a lone pair. Water here, it will react as an acid. So, acid will donate a proton to weak base. And then, because nitrogen have lone pair, it can accept a proton from H2O. Okay, because of that, it will form. Right. Okay, next step, we have to draw the ice table. Alright, so here is the ice table. So you can substitute the initial concentration, 0.01. Okay, change in concentration and concentration at equilibrium. Alright, so now write the Kb expression. Remember, H2O is not included because the phase here is in liquid. Okay. Right, so now substitute from the ice table. And the value of Kb here is 9.6. 10 power of negative 4. Okay, because the here is 10 power of negative 4, so therefore you have to apply the 5% test. Before that, you have to calculate the x values. So you have to write, assume x is very, very small compared to 0.01. So therefore, 0.01 minus x is approximately to 0.01. Alright, next, when we substitute here, okay, find out the value of x. So from here, we'll get value of x is equal to 3.0984 times 10 power of negative 3. Alright, so next, apply the 5% test to ensure whether the approximation can be applied or not. Alright, change is referred to the value of x over initial. So when you calculate here, you will get 0.3098, which is greater than 0.05. So therefore, cannot use approximation method. Okay, why? Because the value of x is very big. So therefore, you have to solve the problem by using quadratic equations. Right, so find out the quadratic equation. Suppose you get x squared plus 9.6 times 10 power of negative 4x minus 9.6 times 10 power of negative 6 equals to 0. Find out the two value of x. So x1, suppose you get, whereas for the x2 here, go back to our ice table. So actually, the value of x here is referred to the concentration at equilibrium. Right, so therefore we can choose the negative values since concentration cannot be negative value. So this one we accept. Okay, x2 not accepted. Okay, from the value of x1, x2, we accept the x1. So x1 actually is referred to the concentration of OH minus. Forget to write the unit or need for the concentration should be molar. Alright, so now our target here is to calculate the pH. However, we only have the information about OH minus. Right, so the next step, you can calculate the concentration of H3 plus ion. So there are two methods. Method 1, so you can use the formula of Kw. So therefore, we can find out the value of H3O plus Kw over concentration of OH minus. Right, so just substitute Kw and the value of concentration OH minus. Okay, from here you will get the concentration of H3O plus, okay, 3.7661. Alright, so the next step you can calculate by using formula of pH. Substitute the values and you will get here 11.42. Alright, for the second method, then calculate value of POH. Okay, value of POH here is 2.2.58. Right, next by using the value of pH plus POH equals to 14, you can find out the value of pH. So there are two methods that you can use. Okay, right, so how many marks that are you going to get from this calculation? So, okay, the first mark, when you write the equation, 1 mark. Ice table, okay, you will get 3 marks. Okay, next, KB expression, substitution. Alright, and then you write the assumption here, 1 mark. Okay, and the value of x okay, so 5%, 5% test is 1. Okay, and then quadratic 1, 2 value of x, and you have to show whether accepted or not accepted, 1 mark. Okay, and then the concentration of OH minus, 1 mark. Okay, so this one, you calculate the concentration of H2O plus, 1 mark. Formula pH, 1 mark, and pH values. So for method 2, you calculate the POH, 1 mark. Okay, formula pH plus POH is equal to 14, 1 mark. And values of pH is another 1 mark. Okay. Alright, next we move to the last question. That is 5. Question number 5. So the percentage of ionization of 0.01 molar NH3 was 4.2%. Calculate the kPH. So the question start with percentage of dissociation. Alright. So from here, okay, so we want to calculate Kb. So Kb, which means the concentration of the product divided by the reactant should be at equilibrium. So therefore, you have to solve by using ice table. Right, so we start with writing the weak base dissociation equation. So this is weak base. So weak base here, it has lone pair on the nitrogen atom. Okay, so it can accept a proton from water. water here reacts as an acid. So it become NH4 plus, okay, equals. And form OH minus aqueous. Alright, next step, you can draw the ice table. Here is the ice table. Okay, now substitute the initial concentration change, and at equilibrium. So now actually our target, we want to calculate the Kb. So therefore you have to find out the concentration of the reactant and products at equilibrium. So we have to solve the value of X. So one more information here is refer to the percentage of ionization. Right, so we can use the percentage of ionization to calculate the value of X. Right, so first write the formula. Okay, so give time 100%. So given to you, the degree of dissociation is 4.2. Change in concentration is referred to X. That's what we want to find out. Initial here is 0.01. So we can find out the value of X. That is 4.2 times 10 power of negative 4. Okay. Right. So now we can find out the value of Kb by substituting the value of X. So write the Kb expression. So Kb. Okay, and then substitute. Okay, and then substitute the X values. Okay, so we will get here the value of Kb. Okay, now how many marks that you are going to get from this calculation? So first is the equation, ice table, you will get 3 marks. Okay, next, formula, value of X. Okay, and then Kb expression, substitution, and Kb final answer. No unit. Okay, alright. So I think that's all for today. So this is the last question here. So we see again in the next lesson. Okay, bye. Thank you and Assalamualaikum.